Now, using the same chart, I can reflect the critical path method here, or CPM. CPM identifies the elements that constrain the total time for a project. Those are determined by examining each activity and figuring out its discrete time. We will determine early start, early finish, and late finish times for each activity. And as such, we can look at what we need to make sure is done first and done well with no schedule slippage in order to achieve our project time goals. Critical path method is an essential tool for a project manager to achieve project schedule. The PERT chart, another graphic tool, reflects each activity assigned on a project, either as pessimistic, most likely, optimistic during its duration. We use this in combination with CPM to identify risks that we have in a project. And notice the combination of pessimistic, likely, and optimistic estimates will give us a better sense of the reality of a project and what deviations we might have of the duration. It helps us assign probabilities for each of these risks and to deal with them appropriately. Crashing is a concept where the project manager adds resources to a critical path or near critical path activity on a project to shorten a project's duration. In other words, make it happen. A project is fully crashed when the reallocation of resources toward the critical path don't shorten the schedule. In other words, adding resources won't make it go faster. Obviously, this is how a project manager trades off schedule and resource costs, part of the iron triangle. Frequently, project managers are asked by management how to do this. Can we make the project finish faster? The project manager's response should be, perhaps, by adding resources, I'll need to look at the critical path and figure out what kind of resources that we can be able to do so. But if we do that, there's a cost. This is the part that's often forgotten. Now, this is also an opportunity for quality, as I say. When crashing is likely to be occurring on a project, it's a good time to get your quality antenna up and start sensing for opportunities or risks with quality. Another technique related to crashing is resource-constrained scheduling. Here we're looking at the activities that are scheduled so that the predetermined resource available pools are not exceeded. For example, we might have a group of developers that will be available. How can we organize the activities so that we don't exceed the number of developers that we need on a project? Again, a type of analysis to look at when we want to manage costs. And to do that, we may prioritize tasks when there's not enough resource available, or we may have to delay the overall project completion until it is. This can be a situation when you have a common resource that's assigned to multiple projects, and they're all of equal priority. Now let's take a look at tracking and controlling activities. What do we need to do for project tracking, and what do we need to do for controlling? One of the things we need to keep track of is when we transition from one phase to another in our project. So what we might call phase transition control. There's a number of different methods to do that, but a couple of common methods include project reviews on an ongoing basis. Typically at the end, almost certainly should be done at the end, we review our project. When we transition between stages is a good time as well. If our project is part of an overall program, recall that that is a set of related projects. A stage transition or a phase transition is a good time to do an overall program review and to look at how our projects are interrelating to each other and helping each of them achieve their own project goals. For schedules to work, the milestone length should match the project volatility What we mean by that is we don't want to have tasks that are so long that change is going to occur. Recall what we talked about before. The customer may change, or requirements may change, or the technology may change. We need to be optimistic in the overall vision of our project and skeptical about the schedule. Did we get all of the tasks in the schedule? Will people perform to the level that we need them to have? Are there any uncertainties that we're going to have to deal with? If we're going to emphasize particular tasks to be successful on a software project, we want to bet on the overall design. The design is the key to that, and you'll see that later. It's central in software quality as well. And we need to plan for discussions, particularly if in the commercial software development market, but even for IT systems, to have frequent conversations about what we need to add or what we need to cut from the scope and requirements that we need to face. You may not make such additions or cuts, but you need to be skilled at making and having the conversations. And lastly, get comfortable with taking on risks early. Often quality problems come because we didn't address risks soon enough, and we're out of time, budget, or will to address what needs to be addressed. So do so early. Now, let's spend a little bit of time taking a look at risk.